Hello, my name is Justin Dubin. I'm a third-year aerospace engineering student at Georgia Tech, and today I'm going to be presenting my results on my study of combustion dynamics in a Reiki tube. A Reiki tube is a pulse combustor that converts heat to sound by adding it in phase with pressure pulsations. Our motivations for studying this are to explore the nature of oscillations and resonance, and to work with a reacting flow in a lab. We measure pressure pulsations using 3 piezoelectric pressure transducers and flame pulsations using a photomultiplier. This experiment was conducted in 4 parts: a 0-inch flame height with open and closed valves, a 2-inch flame height with closed valve, and an experiment in which we determine the flame height where pulsations will cease. We are given raw pressure data in root mean square voltage. In order to determine the sound these waves will produce, we convert to millivolts and then use the chart on the right to find the root mean square pressure. From there, we use the equation beneath the chart to find the sound pressure level in decibels. Resonant frequency can be calculated simply from the speed of sound at nominal conditions and the length of the Reiki tube. The results of this experiment can be seen over the next few slides. We start with the resonant frequency and the relative phase angles and peak frequencies at a 0-inch flame height. Here we continue with the 0-inch closed trial and open trial, where we detail the frequency and amplitude at each transducer position. We once again continue with the 2-inch closed valve trial, where we have frequency and amplitudes for each transducer position. And finally, we have the cessation trial, where we determine that pulsation stops when the flame is at a height of 5.25 inches. The conclusions we drew from this experiment were that heat added in phase with pressure oscillations creates an audible standing wave. And the reason for this is that we are adding heat in phase with the resonant frequency, which means that the amplitude of the output is greatly increased, moving it into the audible range for humans. We also determined that moving the burner vertically and opening the valve decreased the amplitude of the sound.